Hello, everyone. Today, we're diving into a concerning trend affecting thousands of vehicles: premature solenoid block failures in Chrysler's 62TE six-speed automatic transmissions. As a former mechanical engineer at Chrysler, I've seen firsthand how these failures develop and impact vehicle reliability. This issue affects multiple vehicle lines and has become increasingly common in recent years. To understand this issue, we need to examine the solenoid block itself. Here's a detailed diagram showing the various solenoids and their functions within the transmission system. This valve body diagram shows how these solenoids integrate with the transmission's hydraulic control system. Each solenoid has specific resistance values and functions that are critical for proper operation. Throughout this series, we'll explore why these solenoid blocks fail prematurely, which vehicles are most affected, and what solutions are available. We'll examine fluid contamination, overheating, design limitations, and provide expert recommendations for prevention and repair. The 62TE is a six-speed automatic transmission specifically designed for front-wheel drive Chrysler vehicles. This transmission represents a significant evolution in automotive engineering. To understand what makes the 62TE unique, we need to look at its evolution. The 62TE is built upon the foundation of the earlier 41TE transmission, which was a four-speed automatic. The key advancement was adding a compounder unit to achieve the additional gear ratios. This evolution increased complexity, but provided better fuel economy and performance through more precise gear selection. The 62TE is specifically designed for transverse engine applications. Let me show you what this means compared to traditional inline engine mounting. The transverse configuration is ideal for front-wheel drive vehicles because it allows for a more compact engine bay and better weight distribution. The 62TE transmission is specifically engineered for this sideways engine orientation. Now let's examine the internal complexity of the 62TE transmission. This cross-sectional view reveals the intricate engineering required to achieve 6 forward speeds in a compact transverse package. The 62TE's complexity comes from its multiple clutch packs, planetary gear sets, and sophisticated hydraulic control system. All of these components must work in precise coordination to deliver smooth shifting across 6 forward gears and reverse. When a solenoid block begins to fail in a 62TE transmission, it produces several distinct symptoms that drivers and technicians can identify. These symptoms typically fall into 4 main categories. The first category involves shifting problems. A failing solenoid block causes erratic or harsh shifting between gears, delayed engagement when shifting into drive or reverse, and the transmission getting stuck in certain gears. The second category covers performance issues. Drivers experience gear slippage, especially under load when accelerating or climbing hills. The transmission may also produce shuddering or vibration during operation. The third category includes warning indicators. The transmission warning light or check engine light will illuminate, often accompanied by diagnostic trouble codes related to solenoid performance. The transmission may also overheat due to improper operation. The most severe symptom is limp mode, where the transmission control module detects a serious problem and locks the transmission into a single gear, usually second or third, to prevent further damage and allow the vehicle to reach a service facility. These symptoms occur because the solenoids control hydraulic pressure throughout the transmission. When they malfunction, the precise control needed for smooth operation is lost, resulting in the various problems drivers experience. Fluid contamination stands as the primary culprit behind solenoid block failures in the 62TE transmission. Understanding this critical issue is essential for preventing costly transmission problems. The 62TE transmission is extremely sensitive to the quality of its transmission fluid. Unlike some transmissions that can tolerate moderate contamination, the 62TE requires pristine fluid to function properly. Clean transmission fluid flows smoothly through the intricate solenoid passages, allowing precise control of hydraulic pressure. Each solenoid contains tiny passages that must remain unobstructed for proper operation. However, when transmission fluid becomes contaminated with debris, metal particles, or degraded fluid compounds, these tiny passages become clogged. This contamination acts like a dam, blocking the precise fluid flow needed for proper solenoid operation. Transmission fluid degrades over time, changing color from bright red when new to dark brown or black when severely contaminated. This color chart shows the progression of fluid degradation and when action is required. Regular fluid changes are absolutely crucial for preventing solenoid block failure. Fresh, clean fluid ensures proper solenoid operation and extends transmission life significantly. Understanding fluid contamination as the primary cause of solenoid block failure empowers vehicle owners and technicians to take preventive action, ultimately saving thousands in transmission repair costs. High operating temperatures represent another major factor in solenoid block failures. When transmissions run too hot, multiple damaging processes begin to accelerate. Heat directly damages the solenoid components themselves. The electromagnetic coils can overheat, causing insulation breakdown and electrical failures. The metal plungers can warp or stick due to thermal expansion. Even more critically, high temperatures rapidly degrade the transmission fluid itself. Clean fluid is essential for proper solenoid operation, but heat breaks down the fluid's molecular structure. This fluid color chart shows the progression of fluid degradation. Fresh transmission fluid is bright red and flows smoothly. As heat breaks it down, it becomes dark, thick, and contaminated with particles that can clog solenoid passages. This overheating problem is especially severe in specific driving conditions. Vehicles used for towing heavy loads generate excessive heat, as do those frequently driven in stop-and-go traffic where the transmission works harder. In both scenarios, the transmission generates far more heat than normal operation. The cooling system becomes overwhelmed and temperatures soar beyond safe operating limits, accelerating all forms of component degradation. The critical insight is that overheating creates a cascade of failures. High temperatures degrade the fluid, the degraded fluid clogs and damages the solenoids, and the damaged solenoids cause complete transmission failure. This is why thermal management is absolutely essential for 62TE longevity. Solenoids in the 62TE transmission are mechanical components that experience natural wear and tear through their normal operation cycle. Understanding this degradation process is crucial for predicting transmission lifespan. Every time the transmission shifts gears, solenoids cycle between energized and de-energized states. This constant switching creates mechanical stress on internal components including springs, seals, and electromagnetic coils. Inside each solenoid, multiple components experience gradual deterioration. Springs lose their tension through metal fatigue, rubber seals harden and crack from heat exposure, and electromagnetic coil insulation breaks down over time. The wear process follows a predictable timeline. New solenoids operate flawlessly, but by 50,000 miles, microscopic wear begins. At 100,000 miles, performance degradation becomes noticeable, leading to frequent problems by 150,000 miles and eventual failure around 200,000 miles. In real transmission assemblies, multiple solenoids work together under demanding conditions. The rate of wear depends on several factors, including operating temperature, fluid quality, duty cycle, electrical stress, and original manufacturing quality. These common failure modes result directly from accumulated wear over time. While each failure mechanism has specific causes, they all share the common factor of material degradation through repeated stress cycles. This makes wear-related failures inevitable but predictable. Understanding that solenoid wear is a natural part of the transmission's lifespan helps in planning maintenance schedules and setting realistic expectations for component replacement. This inevitable degradation process is simply the cost of mechanical operation over time. Valve body wear is another critical factor that contributes to solenoid block failures in the 62TE transmission. Understanding how this wear develops and impacts the entire system is essential for proper diagnosis and repair. The valve body is a complex aluminum casting containing numerous channels, passages, and chambers. These intricate pathways direct pressurized transmission fluid to various clutches, bands, and control systems throughout the transmission. Over time, constant fluid flow and pressure cycling cause gradual wear in the valve body channels. Aluminum particles from the casting mix with the transmission fluid, creating an abrasive slurry that accelerates the wear process. As valve body channels wear and enlarge, They create cross leaks between high and low pressure circuits. This internal leakage disrupts the carefully calibrated pressure balance that the transmission control system depends on for proper operation. When valve body wear creates pressure imbalances, the solenoids must work much harder to compensate. They cycle more frequently and operate outside their optimal pressure ranges, leading to accelerated wear and premature failure of the entire solenoid block. This is why valve body inspection is absolutely critical when replacing a failed solenoid block. Simply installing new solenoids into a worn valve body often results in repeated failures. The valve body must be carefully examined for wear, scoring, and proper channel dimensions. Remember, addressing valve body wear is essential for long-term transmission reliability. Ignoring this component during solenoid block replacement often leads to premature failure of the new parts and costly repeat repairs. The 62TE transmission's problems aren't just due to wear and contamination. The design itself has fundamental limitations that make it more prone to failure under demanding conditions. The 62TE is built upon the foundation of the older 41TE, also known as the A604, which was a 4-speed automatic transmission designed in the 1980s. While this original design was proven, it had inherent architectural limitations. To create the 6-speed 62TE, engineers added a compounder unit to the existing 4-speed architecture. While this achieved the additional gear ratios, it created a transmission that was essentially a compromise between the old and new technology. Looking at the internal structure of the 62TE, we can identify several key design limitations that stem from adapting an older architecture for modern demands. First, the cooling capacity is inadequate for a 6-speed transmission. The original 4-speed cooling system wasn't designed to handle the additional heat generated by the extra gears and complexity. Second, the hydraulic routing became much more complex when the compounder unit was added. This creates more opportunities for pressure losses and cross leaks within the system. Third, the additional components create increased internal stress on the original 4-speed components, which weren't designed to handle the extra load and complexity. Finally, the fluid flow paths are limited by the original design constraints, leading to inadequate lubrication and cooling in critical areas. These design limitations become critical problems under demanding conditions. Heavy towing, high operating temperatures, and frequent stop-and-go driving all expose the weaknesses in the 62TE's adapted architecture. The 62TE represents a classic engineering compromise between cost and performance. While adapting the existing 4-speed design saved development costs and time, it came at the expense of long-term durability and reliability. This compromise explains why the 62TE is more susceptible to problems under demanding conditions. The design limitations are not manufacturing defects, but rather inherent characteristics of adapting an older architecture for modern performance requirements. While fluid contamination and overheating are the primary causes of solenoid block failures in the 62TE transmission, electrical issues can also damage these critical components, though they occur less frequently. Solenoids are electromagnetic devices that rely on precise electrical signals to control transmission fluid flow. Each solenoid contains a coil of wire that creates a magnetic field when energized by the transmission control module. The most common electrical problem affecting solenoids is voltage spikes. These are sudden, brief increases in electrical voltage that can occur due to various factors in the vehicle's electrical system. Several electrical system problems can generate voltage spikes or cause wiring issues that damage solenoids. These include alternator voltage regulation problems, improper jump starting procedures, faulty wiring harness connections, corroded electrical connectors, and poor ground connections. When voltage spikes occur, they can exceed the solenoid's design limits. While solenoids are designed to operate at 12 volts, spikes can reach 15 to 20 volts or higher, potentially burning out the delicate wire coils inside the solenoid. While electrical problems should not be ignored during diagnosis, they represent only about 10% of solenoid failures. Fluid contamination and overheating account for roughly 90% of cases. Proper electrical system maintenance is important, but addressing fluid quality and cooling issues should be the primary focus for preventing solenoid block failures. Ram Promaster vans represent one of the most problematic applications for the 62T transmission. These commercial vehicles face unique challenges that significantly increase transmission failure rates. These vans are predominantly used in delivery services and commercial operations, where they must carry heavy loads throughout their daily operations. This constant heavy loading places enormous stress on the transmission system. The constant heavy loading creates significant stress on the transmission. Every acceleration from a stop requires the transmission to handle maximum torque loads, putting particular strain on the solenoid block's pressure control systems. The stop-and-go nature of delivery driving creates the worst possible conditions for transmission longevity. Frequent stops followed by heavy acceleration under load forces the solenoid block to work continuously at maximum capacity. This combination of heavy loads and stop-and-go driving results in significantly higher failure rates for ProMaster vans compared to passenger vehicles. The solenoid block experiences premature wear, often failing before the typical 100,000-mile mark. Ram ProMaster vans serve as a prime example of how vehicle application directly impacts transmission longevity. The demanding commercial use creates the perfect storm of conditions that accelerate solenoid block deterioration. The Dodge Grand Caravan and Chrysler Town Country minivans represent a significant portion of vehicles affected by 62TE transmission solenoid block failures. These popular family vehicles have been experiencing high rates of transmission problems. These minivans show particularly high failure rates for the 62TE transmission, typically manifesting after 75,000 miles of operation. Due to their popularity as family vehicles, they represent a large portion of the total affected fleet. The primary factor contributing to transmission failures in these minivans is towing stress. These vehicles are frequently used to tow trailers, boats, and other recreational equipment, which places significant additional load on the transmission system. Beyond towing, these minivans experience additional stress from typical family use patterns. Frequent loading and unloading, stop-and-go city driving, extended idling periods, and heavy cargo loads all contribute to accelerated wear on the transmission components. The combination of towing stress and intensive family use creates the perfect conditions for solenoid block failure in the 62TE transmission. The solenoids, which control fluid flow and shifting operations, become overwhelmed by the demanding operating conditions these vehicles regularly experience. These popular minivans represent the largest segment of vehicles affected by 62TE solenoid block failures. Their demanding use patterns, combining towing capabilities with intensive family transportation needs, often exceed the design limits of the transmission system, leading to premature component failure. Online automotive forums provide a wealth of real-world data about transmission problems. When we examine posts about the 62TE transmission, a clear pattern emerges of widespread solenoid block failures. Let's examine several typical repair stories posted by vehicle owners. These accounts range from minor shifting issues caught early to complete transmission failures that could have been prevented with timely intervention. To understand why these failures are so common, we need to see the complexity of the solenoid block system. This detailed parts diagram shows the intricate network of solenoids, valves, and passages that must work in perfect harmony. The forum stories reveal several critical insights. First, most failures occur between 75,000 and 120,000 miles. Second, early symptoms like delayed engagement or rough shifting are often ignored until major damage occurs. These anecdotal reports consistently emphasize one crucial lesson. Early diagnosis and prompt repair can save thousands of dollars. Vehicle owners who addressed minor symptoms early typically spent $800 to $1,500 less than those who waited until complete failure. The widespread nature of these online reports underscores that 62TE solenoid block failure is not an isolated problem, but a systemic issue affecting thousands of vehicles. This anecdotal evidence provides valuable, real-world validation of the technical problems we've discussed. Transmission rebuilders have unique insights into the 62T's problems. Their hands-on experience rebuilding hundreds of these transmissions reveals consistent failure patterns that point directly to the solenoid block as a major weakness. Professional transmission rebuilders consistently report that approximately 70% of 62TE transmissions they rebuild have solenoid-related failures. They see these failures most commonly between 80,000 and 120,000 miles. Rebuilders note that contaminated transmission fluid is almost always present when solenoid blocks fail. The debris clogs the tiny passages in the solenoids, causing them to stick or operate erratically. Rebuilders have identified specific failure patterns in the solenoid block. The torque converter clutch variable force solenoid typically fails first, followed by the line pressure solenoid, which is critical for proper shift quality. The clutch control solenoids are also frequent failure points, causing the harsh shifting and erratic behavior that customers first notice. Rebuilders see this progression repeatedly in their shops. Professional rebuilders strongly recommend replacing the entire solenoid pack rather than individual solenoids. They've learned that when one solenoid fails, others are usually close behind due to the same contamination issues. They also emphasize the importance of inspecting the valve body for wear, using high-quality replacement parts, and completely flushing the system. Many rebuilders now recommend auxiliary coolers to prevent future overheating issues. The consensus among transmission rebuilders is clear. The 62TE solenoid block represents a fundamental weak point in the transmission design. Their collective experience rebuilding thousands of these units provides invaluable insight into preventing and addressing these failures. Experienced transmission technicians who work with 62TE transmissions daily have developed strong opinions about maintenance intervals based on real-world observations. There's a significant difference between factory-recommended maintenance intervals and what experienced technicians actually recommend for transmission fluid changes. Technicians typically recommend changing transmission fluid 2 to 3 times more frequently than the factory schedule, especially for vehicles subjected to heavy use conditions. Technicians understand that real-world driving conditions are often much more demanding than the ideal conditions assumed by factory maintenance schedules. Heavy use scenarios include towing, stop-and-go traffic, commercial applications, and mountain driving. Technicians recommend more frequent fluid changes because they understand that heavy use conditions cause transmission fluid to break down faster, increase contamination levels, and put additional stress on transmission components. They know that preventive maintenance costs far less than transmission rebuilds. As one experienced technician put it, they see the transmission failures that result from following factory maintenance intervals too strictly, especially in vehicles that experience demanding real-world conditions. This expert opinion from the field provides valuable insight into the gap between manufacturer recommendations and the reality of transmission maintenance needs in demanding applications. The automotive aftermarket has responded to widespread 62TE transmission failures by developing enhanced components that address the transmission's inherent weaknesses. These solutions focus on 3 key areas: improved solenoids, upgraded valve bodies, and enhanced cooling systems. First, aftermarket manufacturers have developed improved solenoids with better materials and tighter tolerances. These upgraded solenoids resist contamination better and provide more consistent performance over time. Second, aftermarket valve bodies feature improved machining precision and modified fluid passages. These upgrades reduce internal leakage and provide better pressure control, addressing one of the primary failure modes of the original design. Third, enhanced cooling systems address the overheating issues that plague the 62TE. Aftermarket transmission coolers provide additional heat dissipation capacity, keeping fluid temperatures within optimal operating ranges and extending component life. These aftermarket solutions work together as a comprehensive upgrade package. Improved electrical connections ensure reliable solenoid operation, while the combination of better components and enhanced cooling creates a more robust transmission system that can withstand the demands of modern driving. The aftermarket response demonstrates that while the 62TE has inherent design limitations, these can be effectively addressed through engineering improvements. These solutions provide vehicle owners with viable alternatives to complete transmission replacement. Modern diagnostic technology has revolutionized how technicians identify transmission solenoid block problems. Today's sophisticated scan tools can pinpoint issues with unprecedented accuracy. Gone are the days of guesswork and trial and error repairs. Modern diagnostic equipment can communicate directly with the transmission control module to identify specific solenoid malfunctions. These diagnostic tools can monitor solenoid operation in real time, measuring electrical resistance, response times, and fluid pressure changes. This allows technicians to see exactly which solenoids are failing and why. Professional technicians now use sophisticated diagnostic procedures that go far beyond simply reading fault codes. They can perform active tests, monitor live data streams, and even command individual solenoids to operate. When solenoid problems occur, modern scan tools display specific diagnostic trouble codes that pinpoint the exact issue. These codes provide detailed information about which solenoid is failing and the nature of the problem. This diagnostic precision eliminates unnecessary part replacements and reduces repair costs. Technicians can now confidently identify whether the problem is a single solenoid, the entire solenoid pack, or related valve body issues, leading to more effective and economical repairs. Preventative maintenance is the most cost-effective strategy for extending the life of your 62TE transmission and preventing costly solenoid block failures. The financial benefits of regular maintenance become clear when we compare costs. Regular transmission fluid changes cost around $150 to $200, while a complete solenoid block replacement can cost $2,000 to $4,000. Regular transmission fluid changes are the cornerstone of preventative maintenance. Clean fluid keeps solenoids operating smoothly and prevents the contamination that leads to failures. Clean transmission fluid is essential for proper solenoid operation. Contaminated fluid can clog the tiny passages within solenoids, causing them to stick or malfunction completely. For optimal protection, transmission fluid should be changed every 30,000 to 50,000 miles, or every 2 to 3 years. Vehicles used in severe conditions like towing or frequent stop-and-go driving should follow the shorter intervals. Following a proper maintenance schedule can extend transmission life from an average of 100,000 miles to over 200,000 miles. This represents a significant return on investment for the cost of regular fluid changes. Regular transmission maintenance is not just recommended, it's essential for preventing costly solenoid block failures. The small investment in routine fluid changes pays enormous dividends in transmission longevity and reliability. As automotive technology continues to advance, the 62TE transmission is gradually being phased out of production. Newer, more sophisticated transmission designs are taking its place in modern vehicles. The evolution of automatic transmissions shows a clear progression toward more gears and better efficiency. The 62TE represents a transitional technology that bridged older 4-speed designs with modern multi-speed transmissions. Modern transmissions offer significant improvements over the 62TE. 8 and 9-speed automatics provide better fuel economy and smoother operation. CVT transmissions eliminate fixed gear ratios entirely, while dual-clutch systems offer lightning-fast shifts. Modern manufacturing facilities are producing these advanced transmissions with improved precision and quality control, addressing many of the issues that plagued earlier designs like the 62TE. The challenges experienced with the 62TE have provided valuable lessons for transmission engineers. These insights are being incorporated into new designs to prevent similar issues from occurring. Future transmission designs will incorporate lessons learned from the 62TE experience. Enhanced durability through better materials, smart diagnostic systems for predictive maintenance, and seamless integration with electrified powertrains represent the next generation of transmission technology. While the 62TE transmission is being phased out, its legacy continues to influence automotive engineering. The lessons learned from its challenges and limitations are driving the development of more robust, efficient, and reliable transmission systems for the future. The most critical recommendation for preventing 62T solenoid block failures is implementing an aggressive transmission fluid change schedule. This single step can dramatically extend your transmission's life. Let's compare the standard manufacturer schedule with an aggressive maintenance approach. The standard recommendation calls for fluid changes every 100,000 miles under normal conditions. However, for the problematic 62TE transmission, especially under severe driving conditions, we recommend changing the fluid every 30,000 to 50,000 miles using high-quality synthetic transmission fluid. Certain driving conditions accelerate transmission fluid degradation and require more frequent changes. These include towing heavy loads, stop-and-go city driving, and operation in extreme temperatures. Regular visual inspection of your transmission fluid is crucial. This chart shows how fluid color and consistency indicate its condition. Light pink fluid is healthy, while darker burnt fluid requires immediate replacement. High-quality synthetic transmission fluids offer superior protection compared to conventional fluids. They provide better thermal stability, resist oxidation longer, and maintain their lubricating properties under extreme conditions. This comparison shows acid formation in different transmission fluids. Higher acid levels lead to increased wear and component damage. Premium synthetic fluids like those with advanced additives show significantly lower acid formation, protecting your transmission longer. The cost-benefit analysis clearly favors aggressive maintenance. While frequent fluid changes cost more upfront, they prevent expensive transmission repairs. You can save thousands of dollars by investing in preventive maintenance. Remember, aggressive fluid change schedules using high-quality synthetic fluids are the single most important step you can take to prevent 62TE solenoid block failures and extend your transmission's life. One of the most effective ways to prevent solenoid block failures in the 62TE transmission is through cooling upgrades. Adding an auxiliary transmission cooler can significantly extend transmission life. Excessive heat is the enemy of transmission fluid and solenoids. When the 62TE transmission overheats, the fluid breaks down, creating contaminants that clog solenoid passages and cause failures. An auxiliary transmission cooler works by providing additional cooling capacity beyond the factory radiator cooler. Hot transmission fluid flows through the auxiliary cooler before returning to the transmission. The system works in series. Fluid flows from the transmission to the factory cooler in the radiator, then through the auxiliary cooler for additional heat removal before returning to the transmission. The benefits of auxiliary cooling are substantial. A properly sized auxiliary cooler can reduce transmission operating temperatures by 20 to 40 degrees Fahrenheit, preventing fluid degradation and extending solenoid life. Auxiliary cooling is especially critical for vehicles used in demanding conditions. Heavy-duty applications like towing put extra stress on the transmission, while hot climates increase operating temperatures beyond design limits. Installing an auxiliary transmission cooler is a smart investment. At a cost of $150 to $400, it's far less expensive than a transmission rebuild, which can cost $3,000 to $5,000. For vehicles prone to overheating, this upgrade can prevent costly failures and extend transmission life significantly. When replacing a solenoid block in a 62TE transmission, there's a critical step that many technicians overlook: thoroughly inspecting the valve body for wear and damage. The valve body and solenoid block work as an integrated system. Even with new solenoids, a worn valve body will cause premature failure and poor transmission performance. Let's examine what to look for during valve body inspection. This image shows the intricate channels and passages where wear typically occurs. Key inspection areas include checking for scoring in the channels, verifying bolt hole integrity, and looking for cross-leak paths that can cause pressure loss and solenoid malfunction. Now, let's discuss solenoid quality. This comparison shows the difference between OEM quality solenoids and cheaper alternatives. The quality of replacement solenoids directly impacts reliability and longevity. Cutting corners on solenoid quality is a false economy. Cheap solenoids may fail within months, requiring another costly repair and potentially damaging other transmission components. The recommended approach is to source solenoids from established transmission parts suppliers who specialize in OEM equivalent components. This ensures proper fit, function, and longevity. The premature failure of solenoid blocks in 62TE transmissions represents a complex engineering challenge with multiple interconnected contributing factors. Throughout our analysis, we have identified 6 primary factors that contribute to solenoid block failure's 62TE transmission system. By implementing comprehensive preventative measures, we can significantly improve transmission reliability and reduce long-term maintenance costs. Proper understanding and implementation of these preventative measures delivers measurable engineering benefits across reliability, cost reduction, and service life extension. In conclusion, the 62TE transmission solenoid block failure issue demonstrates the importance of systematic engineering analysis and proactive maintenance strategies in achieving reliable automotive systems. Thank you for your attention to this comprehensive engineering analysis of 62TE transmission solenoid block failures and their mitigation strategies.